All right, this video I will be talking about how to apply Hess's law in questions you will typically see in the following 2 months. Well, not 2 months, 2 weeks. Okay, so this example I'll be using on page 55, so make sure you turn to this page before watching the video and try to glance through. And then the textbook has its own way. It's very similar to mine, but I will use a better approach so you can see clearly how to solve the question. So let's get to it. Now, there are a couple of important informations you have to take here. So the first one, they want to find the enthalpy change of this equation, which is carbon reacting with steam, you can see it's gas, to produce carbon monoxide and hydrogen gas. And they say use these equations, all right, to form this one. So essentially it's very similar to organic synthesis, where you have to form this one to this one. However, for organic synthesis, you have to think the steps. Here, they have given you already. But there's one thing you have to pay attention is the numbers over here. And in the question, well, when I'm solving it, I will be explaining it. So let's get to it. So the first thing is we have to write down what we're looking for. So the question wants us to form carbon plus H2O gas to form carbon monoxide gas plus hydrogen gas. And they're giving us all three of them, so I'm going to write it down now. So essentially, where the following steps are required. First, you write down the equation you're forming, and then now you're going to write the sign over here. And look what's given to us. We're given these three, so I'll quickly copy it down. We got carbon plus oxygen gas equals to CO2. And then we have, don't forget, we have to write this one, delta H. And this one is negative 394. Next one is 2 carbon plus oxygen, 2 CO2 gas. Now you can fast forward it if you want until I write the next one. So, I don't need the textbook now. So we have to use these three equations to form this one essentially. So first of all, we have to write down, what I like to do is I write the three things and then I will write down the one I need. So the one I need is here, so I'll move this one over here to write down this plus H2O equals to carbon monoxide plus hydrogen gas. So what are we looking for? We are finding the delta H, standard enthalpy change of this. So what is the reaction? So we have to use these three. So how do we do that? So here are the steps. So for clear visible representation, I will be using highlighters to highlight the example, but of course generally you won't do that. So let's begin. We need carbon on the left side, 1 carbon. So we have to look at these three equations. Which one has carbon? Yes, equation 1 has carbon. And is it on the left side? Yes, it is on the left side. So we will keep this equation, okay? Because the stuff we need is here. And we will keep this. This one will remain unchanged. Next, we need water, okay? Water. Let's look at this second equation. The second equation, does it have water? Nope, doesn't have water. So we move on to the third equation. So it has hydrogen, oxygen, and water. Yes, we have water over here, but it's on the right side. So what do? We have to bring it to the left side. How do we do it? So we learned this in chapter 34 that we can flip. However, when we flip, the sign will change. So after we flip, you will get 2H2 gas plus, this will equal to 2H2 gas plus O2 gas. So the sign negative will become positive 848. So we do not need this. Now generally you use pencil to do this, so you can erase it if you don't want. And we don't need this. Okay, and then we ask ourselves, is it what we need? We got hydrogen, we got water over here, and we got water here. But what is the problem here? Yes, the mole. The answer wants 1 mole, but we are given 2 mole. How do we make 2 into 1? Now we cannot make this one into 2 because that will change the whole equation. So we have to adjust the equations they've given us. So we have to make 2 into 1. How do we do it? Divided by 2. So this will become H2O, gas, H2, gas, and 1 becomes half, since we're dividing the whole equation by 2. And then, what else do we have to change? Yes, always ask ourselves, do we have to change the enthalpy change? Yes, in this case we have to because we're dividing the whole equation by 2. Therefore, 484 divided by 2, which will have 2, 4, 2. Okay, so we do not need this equation at all. So we have dealt with the first one, carbon, and we have also dealt with the water. Now we move on to the right side of the equation. The right side requires carbon monoxide on the right. So let's look at this equation. The only thing that we have not touched is the second equation. Okay, so the second equation has carbon monoxide, but it's on the left side. So what do? We have to flip the whole equation. Not only that, you will realize, I will skip a bit of steps, that this is 1 mole, but the question gave us 2 moles. So apart from flipping, we also have to divide it by 2 right here. So what we will get is CO2, CO, gas, plus half of oxygen, gas. So we get rid of this. So over here, we will get positive 566 divided by 2, which will be positive 283. So we don't need this as well. And then after doing that, we can highlight what we need. So this one, here, and here. So don't forget we flipped and then divided by 2. That's where this much is left. And finally, hydrogen. Hydrogen, we need 1 mole. So let's have a look. Where do we find hydrogen? In the first equation, do we have hydrogen? Nope. Second equation? Nope. Third equation? Yes. Is it on the right side? Yes. So do we have to move anything? Nope. So you will realize that, okay, the highlighted ones are the ones we need, but there are still others that are here. So what do we do with that? We will use cancellation. So let's have a look. We have 1 mole of oxygen on the left side overall. On the right side, we have half and half. So what we can do is we delete 1 mole and half and half, 1 mole. So let's look at carbon dioxide. 1 mole of carbon dioxide on the right, 1 mole of carbon dioxide on the left. So we delete. So we will be left with carbon, carbon monoxide, water, and hydrogen. And that is exactly what we need. So for Hess's law, it is very useful because the stuff we need, okay, eventually everything will be canceled out. If you cannot cancel out everything, that means you have done calculation mistakes. Okay, so maybe mole is wrong, you flipped it wrongly. So are we done yet? Nope. We have set the equation correct. By setting the equation right, we have also corrected the enthalpy changes. So if you know today, we learned that in the lesson that enthalpy change of first one is equals to the summation of the second one. But this time there are 3, so we just add the 4th one. So there can be many levels, as the analogy was saying. From 1st floor to 9th floor, we can have 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this case, all we have to do is add all of these up. So don't forget, the negative is important. So we do it negative 394 plus 283 plus 242. And finally, you will get positive 131 K joule. That's it. So that is the energy released. You'll be like, sir, why didn't we write kJ per mole? Now the question specified we have to find kJ. So it's not kJ per mole, so we don't have to worry about mole at the moment. Okay, so a quickly review is that the equation you need, okay, you always write it at the end. Draw a straight line and then write the equations that are given. Ask yourself what is on the left side. First we start with carbon. Carbon is over here. The mole, is it the same? Yes. Do we have to move anything? Nope. So we move on to the next one. Water. We noticed water was on the right side. We flipped it and divided by 2 because it was 2 mole. Similar for carbon monoxide, we flipped it and then divided by 2. So the sign changed. And the rest, if everything is correct, everything will be deleted. So essentially, you will realize that the answer will be there, correct. Okay, so that's pretty much. So go through book page 55, and in lesson time tomorrow, I'll be talking more about the questions you'll be doing. Okay, that's it for this lesson.